everybody. Hopefully you can all hear me now. Welcome to Show the Code. This is our latest Show the Code event. This event is in partnership actually for a second time with TechNation Upscale. We ran an event previously with TechNation Upscale in April, which was a huge success. And so we've decided to put the Show the Code event for them back on this month. So really excited to have everybody here. Thank you so much for joining. We've got a really exciting event lined up today. We have 4 companies from the TechNation Upscale portfolio joining us. We actually will be hearing from engineers at each of these 4 companies. So we have Atom Learning, Tillo, Leafgrow, and Blink. And they're really going to be giving us a good insight into the technical challenges, what it's like to be an engineer at these companies, and really talk about sort of their internal engineering growth as their teams. So we're really excited to have everybody come on board. The event will be made up of 15-minute presentations with the opportunity to ask questions at the end of each presentation. I highly encourage everybody in the audience to add your questions to the Q&A section of this event. We'll be able to sort of pick those out at the end of each talk and ask them directly to the speakers. Just to mention, all of the companies here today are hiring. They are looking for engineers to join the team. They're looking to meet and speak with other engineers that are interested in what they're building. So I highly encourage you to connect with each of the speakers, either in Hopin directly or by reaching out to them on LinkedIn or online as well. Now, this Show the Code event is I think it's our 11th event, and it's been in partnership with Silicon Roundabout for a long time. We're super excited to have Silicon Roundabout as a partner. I'm going to start by introducing Francesco, who's the co-founder and director of Silicon Roundabout. He's going to tell you a little bit more about those guys and what they do. And then we'll also go into a few more introductions, that being one from Liam Ward, who is the program manager at TechNation Upscale. And then we'll kickstart the event talk. So Francesco, if you don't mind, would you mind just telling the crowd a little bit more about yourself and Silicon Roundabout?
Great. Thanks, Sam, and grateful and happy to be here and to host such an amazing event in partnership with TechTree. And for those of you who are already part of the Silicon Roundabout community, sorry you'll have to hear my spiel yet again. For those of you who aren't yet part of the community or have come maybe joined very recently, I'm a software engineer myself. I'm actually currently serving as I'm one of the 2 co-founders and directors and the CTO of the academy side of the Silicon Roundabout community, which is currently delivering a couple of projects in the e-learning space. So that's a pretty exciting part of Silicon Roundabout currently happening. And on the other side, managing the Silicon Roundabout Ventures pre-seed, seed, high-tech fund. And the community itself sits across the board on top of these, and it's always a free project for everyone to join. As always has been. We've been running the meetup for 10 years now, since 2011, and the purpose has always been promoting new technology, and that has also been about getting and helping engineers learn about new projects, stay up to date with tech, and share their development and technology. The focus has always been on startups, so trying to always give the forefront to startup and innovation. And as it always happens when it comes to startups, the business side is easy to pitch, not necessarily the engineering side. Hence why the partnership with yet an amazing startup, TechTree, that we love and support. And it's great to be able to have a dedicated space at Silicon Roundabout and, of course, for TechTree to offer engineers and technical speakers from companies a chance to showcase how they are actually building new technologies. And so as Silicon Roundabout, we're all about the community. We do invest in startups ourselves and we build tech ourselves. So always keen to host new engineers, to network, connect to companies, and of course from companies to connect with engineers and spread technology. That's what we're about. That's what we aim to do with this event series and beyond. And thank you all for joining us today. And for me, that's pretty much what we do, what we're about, why we partner out with this amazing startup, which is TechTree. And I really hope you enjoy today and the future of this series that will continue to showcase companies and even apply to join future episodes of this series.
Great. Thank you so much, Francesco. It's a great introduction about Silicon Roundabout. I'll let you leave the stage now, and then I'll start welcoming our next speaker. So thanks again, Francesco. Everybody, next up we have Liam.
See you later, guys.
Bye, Francesco. So now I'm going to welcome on stage Liam Ward, who is the program lead at TechNation Upscale. He's going to give you a short introduction about the Upscale program, but also their visa program, which could be of interest for a few people in the crowd. So Liam, over to you.
Yeah, thank you, Samuel, and hopefully you're all picking me up okay. Thank you so much for the introduction, and great to partner with both TechTree and Silicon Roundabout on today's event. As mentioned, this is our second event, so super excited to be doing this again. For those of you who are not familiar, my name is Liam Ward, and I run the Upscale program here at TechNation. TechNation, we're an organization that are partly backed by government, really with the mission of supporting the UK's most ambitious entrepreneurs and their senior leadership teams. So we, across a variety of, offerings, support the UK's leading tech companies on their growth journeys, be it from early stage, like 2 people in a garage setting up a startup, right the way through to kind of Monzo on our Future 50 program, and everything in between. So alongside our programs, which I'll talk a little bit more about in a second, we also have a number of initiatives to support entrepreneurs, including a data and insights team to talk about what's happening in the ecosystem, for example, jobs and skills, and also a visa team, which is of particular interest, I guess, to the audience today, which enables anybody who wants to work in a UK tech company and has demonstrable technical skills to be able to apply for a visa in about 6 weeks. So it's a tier 1 visa. We're the only endorsing body in the UK of the exceptional digital talent visa. So if you are interested in working in the UK from outside in Europe, then please do just drop me a note, either on LinkedIn or via email. I'm happy to introduce you to the visa team here, because it's a great route into some of the UK's most exciting tech companies. In terms of the Upscale program and the program that I lead, all of the companies that are presenting today are on the Upscale program, which is a 6-month program designed to support their companies and the growth that they're currently going on. So supporting around international expansion, hiring talent, hence this brilliant partnership with TechTree, operations, marketing, finance, really helping the founders and leaders in these companies to get the support that they need as they scale. Scaling engineering teams is always one of their biggest challenges, as is hiring diverse engineers. So we're really, really proud to support this initiative with TechTree and to hopefully continue a long partnership on getting great companies in front of excellent engineers and making sure that everybody wins in the ecosystem. So please enjoy the event. Samuel, Lawrence, thank you so much for having me, and thank you so much for having the companies. Please use the opportunity to check out all of the jobs they have open. The 4 companies are absolutely amazing and represent some of the best of UK tech. So Samuel, I'll pass over back to you. Really looking forward to seeing the presentations today. And if anyone's got any questions, feel free to find me on LinkedIn. Thank
you so much, Liam. Brilliant. That's really helpful. I'll let you lead the stage now as well. So
Cheers,
yeah, again, a big thank you to TechNation Upscale for partnering with us on this event. Just a few things before I introduce the first speaker. I really encourage everybody in the chat to ask questions as each speaker is giving their presentations. I'll then pull those questions out and ask them directly to them at the end of their presentation. We have a poll actually going ahead in the stage section on our chat. I would love for anybody in the audience to take 2 minutes just to click on some of their answers there to give us some feedback about what events you like and what you're looking to achieve. Okay, so without further ado, I'm going to welcome on stage Tim Osborne, who is the CTO at Atom Learning. Atom Learning is an online educational platform who are doing some amazing things to support Key Stage 2 learning and development through their platform. So if Tim could join me on stage, we'll prepare you there. Awesome. Hi, Tim. Welcome.
Hi, everyone. Thanks, Sam. And thanks, everyone, for the welcome. And my name is Tim, and I'm going to be talking to you today about how we've built some adaptive tests at Atom Learning and how we've made those performant, particularly as I'll kind of go into the reasons why we needed to do that in a sec. So Very quick introduction. As Sam said, I'm the CTO at Atom. I joined the company at the very start, once the co-founders, Jake and Alex, had figured out that they had a really cool idea and they wanted someone to build it. And I joined to kind of build the very first version of our platform. My background is in computer science and security. So I previously worked in kind of cybersecurity domain and moved across to build the Atom platform to kind of put all of that stuff that I've learned throughout university and my previous career into practice. I think this is probably true of most startup CTOs, but I still continue to wear many different hats, and I essentially give hats to people as we hire more people. So at the very beginning, I was the only technical person, and we've now grown to have a large team of engineers. I still am quite hands-on the DevOps side, but more or less not as much hands-on on the engineering side anymore. But still kind of fairly involved, and obviously as we grow that will change as most startups happen. So just to take you through what I'm going to talk you through, I'll give you a quick background to Atom Learning, what we do, why we're solving interesting problems. I'm then going to talk you through adaptive tests, so what adaptive tests are, how do they work, and how do ours work. And then why do we care about the performance of these tests, and a couple of solutions that we've had to come up with in order to solve some of the sort of problems that were at the very beginning of our journey on this to build this platform. And then, as everyone said, there's a dedicated time for Q&A at the end, and feel free to ask questions in the chat as we're going along. So very quick introduction to Atom Learning. We're an edtech startup founded in 2018. And we're a learning platform for Key Stage 2 in the UK. So that's the sort of second half of primary school, ages 7 to 11. The whole platform is underpinned by a machine learning algorithm, which is adaptive. So what that means is it kind of, each student is sent on their own personalized journey based on how they're doing on the platform. And today I'm going to talk a little bit about our machine learning algorithm and how that works in an adaptive test. A bit of introductions in terms of people. We have 22 engineers overall at the moment, and we work in cross-functional pods. So those are kind of similar to Spotify squads, where they'll focus on a particular business area. We have around 90 people overall in the company now. We've grown a lot in the last year. I think we went into lockdown with around 20 people. So we've seen a huge amount of growth over this year. And we now have an office in London, but we also have around a third of the company who are fully remote. And yeah, as has been mentioned, we are hiring, and we're hiring across London and fully remote roles into the engineering team. And here are some pre-lockdown and actually one post-lockdown photos of the team there. It's a lot bigger than that now. Very briefly, our tech stack. We have a React front end, which is bundled up and sent to the browser and executed in the browser. And then we have a series of Nest.js backend microservices, which all run on Kubernetes clusters. And then we have a number of different storage techniques. The main one we use is MySQL, but we also have some Mongo databases, some Redis database for sort of high performance stuff, and Elastic we use for all of our logging. So that gives you a very brief overview of who we are and what we do and what kind of tooling we use. So to dive into kind of what are adaptive tests, essentially traditional tests like a paper test that you might sit at school are pretty inefficient. And the reason for that is they require a large range of questions to cover the full range of difficulties. So if you've got a cohort of students, you have to ask, in a paper test, you have to ask every student the same questions. So therefore, you have to have some very, very easy questions for the lower performers and some very, very hard questions for the higher performers. So the idea of an adaptive test is not every student sits the same question. And in fact, it changes depending on how well you're doing in the test. So at a very high level, you can say an adaptive test, if you're doing well, it will get harder. And if you're not doing so well, it will get easier. The reason why this is good and this is beneficial is that overall you require fewer questions to actually assess that student's ability, because you don't need to bother asking the really, really easy questions to the high performers, and you don't need to bother asking the really, really hard questions to the lower performers, because you can say with pretty much certainty that they won't be able to how they're going to answer those questions. So that's the point of adaptivity, and it kind of makes it much more efficient to assess ability. And it also means that we actually can provide a much more accurate score of a student's ability, because if a student gets 90% on a test, they might be a really good student, or it might be that your test just didn't cover a wide enough range of difficulties. So the advantage of doing an adaptive test is, you can kind of get as hard as you possibly can, and really precisely mark these students on their ability. So how does this actually work? This is essentially a logistic regression, if anyone's familiar with those, and it's using a binary classification. So what we're trying to do is we've got kind of our X and our Y values, and we're trying to, our X may be our input, and our Y is essentially true or false in our binary classification. So what we're actually doing in Atom is an inverse of this. So we know the true or the false, and we want to extract two variables, our Y variables, out of that. And the two variables that we're trying to extract are our student ability and our question difficulty. So basically, we know whether students got a question right or wrong, and we're going to extract from that, therefore, how hard was that question based on all of the different students that have sat this question, and how good is that student based on all of the questions that they've sat. So we have two what's called latent variables, so they don't exist in real life. A student doesn't have their ability written on them, or that where you can actually see. So they're approximations of these two properties of the student. And this is essentially something called item response theory. So that's the kind of underpinning mathematical theory that we use to develop our adaptive algorithm. And I'll kind of go into a little bit more detail how that works now. So what we essentially do is collect all the responses from the students. We have around 70 million of these now from Atom, and we plot them in a matrix like this on the right. So we have our students in our columns across the top, and we have our questions in our rows down the side. And then we build a matrix with ones or zeros or empty, depending on whether they got that question right, wrong, or they haven't answered that question yet. So this is essentially what we do, and we model that. And then what we aim to find is a line of best fit through all of that data to give a good approximation for our student ability and our question difficulty out of that. In general, it's, as you can probably assume, students with more ones are going to have a higher ability, students with more zeros are going to have a lower ability. But by modeling this in our algorithm, we can actually get fairly precise readings for both of these variables. And then what we do in the adaptive test setting is, once we have all of these question difficulties, what we can then do is, based on the responses that the student has given in their test so far, we can then approximate their ability in this test. And what we're trying to do is we're trying to find the ideal next difficulty for this student. So once we have the question difficulties and the student ability, we can then give a probability of them getting a question correct. So what that actually means is, in a testing environment, we can say with reasonable confidence, we think this student has a 50% chance of getting this question correct. And what we're trying to do in a test environment is aim for that 50% mark. The reason for that is that's the most efficient way. It's kind of like a binary search. If you're going down a binary tree, you give them with a chance of getting 50% correct or incorrect, and then when you get the result for that, you can then adjust their ability accordingly and pick the next question, moving kind of down the binary tree. In a learning environment, though, that can be quite demoralizing, because the students obviously are getting half the questions they're doing wrong. And so when we're in a learning environment on the rest of our platform and not in a test, we aim for 80%. So 80% is roughly around the right point between not getting everything right and therefore getting demotivated because it's too easy, but also not getting too much wrong that you get demotivated because you feel like you're not progressing. So these are the two sort of target probabilities that we aim for in our learning and our testing environment. So that's a little bit about adaptive tests and how the algorithm works at a very high level. So kind of moving on to why does the performance of these tests matter? So hopefully everyone's engineers, everyone knows that better performance equals, better user experience, and the faster you can deliver things to your end user, it's going to be a nicer experience for everyone. But in our particular case, we actually had a really specific reason why performance really mattered to us. So this is because our tests are timed, and you can't introduce unnecessary delays in between those questions. So if you're doing a paper test, you can move on to the next question as soon as you've completed the page turn, which most people can do fairly quickly. If a student has to wait for 10, 15 seconds or something for the algorithm to pick the next question, whilst in between the questions, then we're introducing a huge amount of delay in those in that test, where the student can't do any questions, but their time is still ticking. And you can't really adjust the time for this because you don't really know how long that delay is going to be, because it could be impacted by network, it could be impacted by how many other users are using the site. All of that sort of stuff is really hard to approximate and adjust the time correctly. So what we needed was virtually zero time between the first question and the second question. So what I'm going to talk you through now is a couple of solutions that we thought about how we may approach solving this problem. So the first one would be to choose the question on the client. So this is where we send all of the possible questions that the student could sit now to the client, as in to the React app, and the client-side code then chooses the selection of the next question. So the advantage of this is it achieves the requirements. We'd be able to swap out the next question pretty quickly because there's no network delay between the choosing of the question and the showing. It's relatively simple to implement because there's no, it's essentially just pick from an array. But the disadvantage of this, the main one, is we'd have to have a very large question bank on the client. And this was kind of unacceptable because we have thousands and thousands of questions now. In order to actually send all of that to the client for them to pick from a really good range of questions, we'd really struggle to actually implement that in a performant way. Secondly, the algorithm that does the picking would need to run on the client as well. So we'd be limited by the hardware that the device that the person was using, and that may end up being a slower picking than if we had it in the cloud, where we can throw as many resources at that algorithm as we need be. So based on that, we didn't do that. And what instead we did was designed a prefetch mechanism. So how this works is the client fetches the next question whilst the student is answering the current one on their screen. So it's loading it in the background and stores it in React state. And then once the student is ready, it swaps it over instantly and they can answer that next question, and the answer to the one that they've just answered goes off to the back end. So advantage of this is it's also performance, so it achieves the requirements. It means that our algorithm can run in the cloud, so we can throw as many resources as we like. And also the size of the question bank it's not totally irrelevant, but it's pretty much irrelevant in terms of the speed at which we're able to pick stuff from the database. Disadvantages of this, it does mean the main one is that we can only select the next question on n-1 questions. So that's to say, if I'm picking question 5 in a test, I only have responses from 1, 2, and 3 available to me to pick from, because question 4 is currently on the student screen and they haven't answered it yet. This was a trade-off that we had to decide whether we were was acceptable to us. But because of the performance gains, we decided that this was worth it. And as long as you have enough questions in your test, any sort of small corrections that need to be made because they got a question wrong, but they were given a slightly harder one afterwards, do even themselves out over the course of a 15-question test. So it's actually acceptable to have this trade-off. It is also slightly more complex, but given the benefits, this is the kind of decision that we decided to take. So to give you a very kind of simple diagram of how this works. Essentially, when the session starts, we fetch question 1. We'll then fetch the next question immediately after that. So question 2 in most cases, unless you're mid-session. And then we'll display question 1 to the student. The student then answers question 1, and we save that response to the database. And then we display question n+1, so question 2, straight to the user immediately, and send off a fetch request for question n+2, so question 3, and so that it loads in the background. And we keep doing that throughout the whole test until we get to question 20, 25, how many questions are in the test, and we've answered all of the questions. And each time, the next question is always loaded in the background. So this is it in action. Hopefully it's probably really small, but on the left here, you can see we're on question 5 on the screen. But in the network tab below, we've loaded question 6 already. And the GIF is tiny, but you can hopefully see that the next question is always immediately sent in from the right, and there's no delay between the different questions, which is the main requirement for the thing. So to kind of sum up, this is a kind of performant and adaptive solution that we came up with. We took into considerations those trade-offs to ensure that it is still performant, but also we accept that we're missing one response each time we're calculating it. But this is still a core piece of functionality. The code, thankfully, is no longer my code, but the principle and the kind of the methodology and the logic is all still the same, and we still use it today. And it's proven that was a scalable and correct decision to make, because as we've expanded our question bank hugely, the option for sending the client all of the questions is completely unfeasible now with the number of questions that we've got. So that is a very, very quick run through of the various challenges that we faced when coming up with how to make these adaptive tests performant on our EdTech platform. And I will happily answer any questions if anyone has any.
Awesome. Hi, Tim. Thanks for the presentation. Really, really interesting. I think fascinating to see your approach to this new way of learning. Perfectly timed. So we've still got 1 or 2 questions from the audience that I'd love to just read out to you and see if you can answer. So we have a question from George, and he's asking, how do you help students who are struggling to move from non-performer to average performer, and same with average performer to high performer, so they don't remain active tests?
Yes, it's a good question, George. Thanks. So this is very specifically on the testing element that we're talking about here. So we are essentially trying to assess that ability as efficiently and accurately as we can. But on the learning side of our platform, we take quite a different approach. So we are, as I say, we increase that probability so that you're in your 80% range for getting things right. And we have loads of explanations and help sheets and videos that we show to students, whether they get them right or wrong. They can kind of choose that path through there. So it's not about us they don't stay, and we don't kind of mark them as a medium performer when they join and they stay there. Their ability is kind of constantly being reassessed based on the most recent answers that they've given. So what we often see on our platform is people will start and they'll do like an initial calibration test, and we'll give them an ability of X. And then as they do more content, as they go through all of the help sheets and the videos and all of that sort of stuff, their ability will move with that. And we can see that it's only in the testing environment where you kind of start from scratch, where you know nothing about the student and you attempt to assess it, where where we aim for that 50% percentage. But in the learning mode, we kind of see that progression so that the AI doesn't kind of just get them stuck on one area. It's very much a moving goalpost that they can continuously improve on, if that makes sense.
Awesome, thanks, Tim. We've got 2 more questions. So Jens is asking here, are there really thousands of possible next questions following each question? There are only a handful of or so answers to anticipate, so could you not pre-compute the next question for all of those and preload at most a handful of questions from there?
Yeah, so that's a very valid point. I think with the number of questions that we have in our bank and the numbers of grades that we have across those questions, it would actually be probably harder to pre-compute absolutely every different possibility. The questions are multiple choice, but as you kind of get, you could get into lots and lots of different possibilities and lots of possible avenues that you go down. And so it's kind of more efficient for us to have all of the difficulties pre-calculated, which we do overnight, and that's a slow process where we grade all of our questions, so we know exactly how difficult each of them are, and then we basically pick a range of based on the small calculation of the student's ability. We can then pick from all of those different questions the most suitable based on their graded difficulty. So there are, when I say thousands, there are thousands in our question bank, but then we actually kind of cut that off into our small kind of remit, sort of range of difficulties that we're looking for. But the problem is at the beginning of a test, you know nothing about the student, so you can't load all of the possible questions where the student might need to sit in that test until you actually know some information about them. So you could do some sort of batching process where you, at various points in the test, you decide to send like the next batch of smaller possible questions, but that wouldn't, it may work, but it kind of introduces almost as much complexity as the prefetch mechanism that we've got. So therefore we kind of took that decision. So we've got that static data of all of our difficulties, and then we pick a range of difficulties that we're interested in, and then we'll just pick one of the questions from that based on that, if that makes sense.
Cool. And just one really quick question for me, just in terms of your engineering team as a whole. You're looking at engineers. Do they need a background in education or education tech? And if would that support them if they did join your engineering team?
Yeah, so you absolutely don't need a background in it. We're very keen for all of our engineers to be incredibly product focused. So we very much want our engineers to care about our product and be behind our mission, and like what they're doing and like that they're contributing something useful to the world. But it's not a requirement. It's very much if you do have experience in edtech or education or teaching or tutoring, that's a really good bonus and a great talking point for interview, but it's definitely not a requirement as long as you are product focused and you are behind the company mission.
Awesome, great, Tim, great presentation. Thank you so much for taking the time today. I will let you leave the stage. If anybody has more questions for Tim, you can message him directly on Hopin. You can even start direct conversations with Tim there as well. So next up, we have our second speaker, who is Mike Ozachowski, who is a senior Scala engineer at Blink. And Blink are building, who I'm sure Mike's going to tell you a bit more about, they're building an app for frontline workers, which is obviously super relevant in today's climate. So Mike, over to you. Looking forward to hearing your presentation. Just test to make sure your presentation goes live first, and then we'll carry on from there.
My presentation today will be about keeping the Blink clients up to date, and in the context of long polygon and Akka cluster. I myself, as you mentioned, is a senior backend developer at Blink. And a few words about ourselves, as the company that sponsors me to be here. So we are an app for front-end workers. Our main goal is to give them the tools, removing any friction from their lives and get them as productive and as engaged in the company that they work for, as this has in the past been a problem for companies which deal with a lot of front-end workers. They have suffered from a lot of turnover. They have suffered from staff not being engaged enough. We try to eliminate that. And for the past couple of years, we have managed to get a lot of traction in that area, and we are currently growing exceptionally fast. So yes, do check us out if you're interested in that particular topic. So the problem we are facing, or we have been facing, is keeping all those clients up to date. So we're obviously dealing with both the frontline workers and the office workers. So we have to keep both the mobile devices and the potential desktop devices up to date. The requirements we have had to deal with are obviously three: reliability. As we are dealing with frontline workers, people who move around, they can move to underground, for example, when there is no network coverage. They can move to buildings, switch between networks. this poses significant challenges to the reliability of the connection they are having from their mobile device to the backend. Also, we have to deal with the people who support them from the comfort of their office. So those people can be behind proxies, that can be behind enterprise firewalls. This introduces further problems to the choice of the solution that we will use to keep the clients up to date. We have to be compatible because we are working within the context of an enterprise environment where you still deal with technologies which are quite old, if you think about a very quickly changing IT environment. So we often deal with old Internet Explorer versions from the browser environment, or we deal with old devices for the frontline people who some of them may have phones that are 10 plus year old. And finally, us, when we started being a relatively small team, we needed the technology to be easy to use, as we were aiming to deliver a big change in the environment rather than spend a year of building our network stack to be reliable. So what are the potential candidates in this space? First of all, we got active polling. That's an age-old solution where the client actively polls the server, just performing a request response to the actual server on a timer and sleeps in between. The good things about it is it's just HTTP request, HTTP response. It works. That's how the internet is built on. That's what the internet is built on. The bad problems with that is latency. Obviously, you can only update when the client actively asks for the data. And it's a resource hog because constantly creating a request response model between the client and the server is the expensive part in the interaction. And you cannot win in this system in that it's a zero-sum game. If you improve one, you lose on the other. If you improve latency, you have more connections, you utilize more resources. The first thing that came around to improve that model was long polling. And the way it changes the model is that it introduces a way for the server to continue keeping the connection open until it actually has something to return to the client. And in this model, obviously the keeping the connection open is far cheaper than reestablishing the connection constantly. We have a better latency because the connection is there waiting for any notifications to be delivered. And we utilize less resources, like I mentioned. The bad thing, obviously, is the potential for message loss, as we are dealing with people who can constantly move in and out of network coverage. There's a potential for message loss where the connection is going to be interrupted at the same time as the delivery started, and the client will reestablish a new connection, new polling connection, where it will receive a new packet of data without actually receiving the previous one. It's potentially resource intensive. That may happen in a situation where your system has a lot of active notifications going through, and the client and server end up constantly polling for very little data. So your client polls for data, receives one notification, gets a response, polls again, one or two notifications, response. Very, very high utilization, very little benefit. And finally, you may need sticky sessions, what is called sticky sessions, depending on how you implemented your backend. If you keep the state of the client or subscriptions for the client in a single place, you may need to introduce a system under which your connections end up on a single machine. So in this case, you give up on any kind of load balancing, and you potentially expose yourself to security issues with regards to denial of service, because if you give someone an ability to target a single machine directly, that can be used to deny that machine any service. The next solution is the one probably most of you have heard about. That's the one most people just think about instantly when they think about keeping the clients up to date. That's WebSockets. That's already a well-established solution as well. It works by establishing a persistent channel, bidirectional channel between the client and the server, by utilizing an upgrade protocol embedded in HTTP. Now, the good things about it is obviously it's extremely fast, low latency, lightweight, bidirectional. However, because the protocol was effectively added as a bonus to the specification, it was added in a very raw form, and it requires additional development time or use of libraries to provide resilience. So the protocol itself just provides you with a channel. It doesn't give you any handshakes, doesn't give you any recovery mechanism when the connection gets broken, any missed content, missed packets, no such thing. So it's also prone to compatibility issues. So like old browsers do not work well with it. I think Internet Explorer, for example, only supported WebSockets from version 10. And while this may be old world for us, it's not for a lot of companies still. There's also problems with proxies and VPNs. And most importantly for us as well is there's a problem with enterprise firewalls. Many enterprise companies just outright ban them. They do not allow WebSockets. Going through the process of enabling them is often painful and long. So they would stop adoption. And at the end of the day, if you use a library, many of them fall back to polling anyway. So you might end up implementing two solutions to one problem. Finally, the newest arrival to this problem is called server-side events. And the way it works is it utilizes the HTTP request response, as most of those solutions do. However, it does something smart. It doesn't provide content length. It doesn't specify content length, and it just continues responding as long as it can, effectively providing a single channel that sends responses to the client for as long as it can. And that would be ideal because, again, it's a standard model that the internet is built on. It handles all the issues that WebSockets do not, because it's been with the knowledge of what WebSockets kind of were bad at. So all the things about disconnects, missed messages, and all those kind of things were built into the spec. However, because it utilizes the HTTP request and response model, there is a problem where the very built-in caching that's part of the internet may literally kill off your communication mechanism, because an old proxy that's not aware of the mechanism may completely buffer your stream and effectively stop any communication you have between yourself and the client. Likewise, it's not supported by a lot of old browsers, including pretty much every version of Internet Explorer, meaning it cannot be a solution for any enterprise that still relies on that browser. So finally, we arrive at the game of elimination. We effectively have 4 solutions, and we had to figure out which one we can go ahead with. Active polling, absolutely not acceptable, too resource intensive, too many problems. WebSocket, likewise, while it's very fast, it's prone to a lot of network issues. It requires quite a lot of development time or using libraries. The problem with libraries is, depending on how many platforms you need to deploy to, you may be lucky and the library will support all those platforms, or you may not, and you end up in a situation where you have a library that doesn't work with a particular platform you need to deploy to. And like I mentioned before, most of them require an implementation of polling anyway. The newest one, server-side events, no IE support basically means we cannot work with it in terms of enterprise clients. So we're left with long polling. There's still load balancing issues, there's still message loss ordering, and there's still resource usage under heavy activity. The question is, can we build the system in such a way that we can deal with those drawbacks? And that's where we can utilize technology. That's where we can utilize some of the frameworks that are available to us. So the first thing we use a framework called Akka. Many of you may have heard about it, but I'm going to do a small introduction. It's a framework that models system behaviors or behaviors in your system in general as small single-threaded state machines called actors. It's a highly asynchronous model and it's a highly parallel model. However, at the same time, it's a very programmer-friendly model in that you effectively deal with a single-threaded processing within the context of the actor. The actor has a mailbox which you can send commands to, and the processing is in order. So the first message that arrives is the first message that gets processed. However, the most important feature for us is that those actors are addressable, which means any actor within the system can send messages to any actor within the system as long as it knows the address of that actor. Now, there are 2 additional features in Akka that made a big difference for us. And that is clustering, which means we can have multiple boxes servicing our system, servicing our core servers that can talk to each other. They can assume different roles. They're resilient to network changes. They're resilient to nodes going up and down. And at the same time, we do not have to think where within the context of the entire system the actor lives in. As long as we know the address of the actor, we can target it. It also provides us with a very efficient binary comms protocol, which is far more efficient than HTTP in terms of distributing change throughout the system. There's also a cluster pub subsystem, which allows us to subscribe actors, which are going to be our termination points for our long polling, to various topics of interest within the system. The system has a very low footprint, as per node, there's only one actor that actually tracks the topic, and a memory footprint of 150 and 512 bytes. And there's only one message propagated per topic per node, as the actual fan out happens in memory. Another very important feature for long polling in this case, and for the entire system, is that you can perform topic subscriptions anywhere within the system on any node, because the topic subscriptions get propagated using the gossip protocol. So the cluster nodes tell each other which actors are interested in what topics, which nodes are interested in which topics. So you can subscribe an actor on one node from another one. So how can we utilize all that tech that I've been talking about to address the three core weaknesses of long polling? First of all, load balancing. The clients establish a polling session, which is terminated on an HTTP server. However, it's represented by an actor. The actor is stateful, it's addressable. That means that the client, if it receives a polling identifier, an actor address, it can then hit any of the machines, any web server, and that can be directed within the cluster to the actual polling actor. So we can utilize load balancing for HTTP connections because we no longer have to think about which server box are we hitting. It also means that the clients can utilize that address because of the gossip protocol to, for example, when fetching any resources, immediately subscribe to those resources again on any of the machines within the cluster. So that's one weakness addressed. The second problem is clients start the message loss and ordering. So we can utilize, again, the statefulness of actors to deal with that, because we can have two buffers, a delivered buffer and a current buffer, with, for example, an auto-incrementing index. And a client can provide us with the information of which of the two it requires. If it successfully got the previous batch, it will ask for the next one. If it didn't, it can ask for a replay of the previous batch. That can be stored in memory, it can be compressed, or it can be stored in a cache system like Redis. If it asks for the new batch, then we just discard of the old cache and we complete the current batch, move it to the deliverable one, and we deliver it. Very, very simple solution because of the statefulness of Akka to get over the message loss and ordering of the responses on the client side. And finally, the last problem with long polling, very well known, is that if we have a lot of activity in the system, long polling suffers because it constantly delivers very small batches of information at a cost of creating and discarding connection. And what we noticed is that in our case, those events tend to be aggregated. So when we deliver, when one of those events arrives via PubSub, many will very soon follow. As they get triggered by the same mechanisms. Usually, one event results in a couple of those notifications. That allows us to utilize the statefulness of actors and the ability for them to effectively turn into a state machine. Because what we can do is we can transform the actor from the waiting state to a delivery state. For example, when there is a polling connection present, when there's something to deliver, we can then delay that delivery for a period of 200, 300, 500 milliseconds, while we aggregate any kind of notifications that still arrive and then deliver them to the client as a single batch. And ideally, hopefully, and in our cases, in most situations, by the time the client requests another polling session, basically we've delivered the entire payload. So we do not pay for this high activity in the system. And that's pretty much it. That is how we can utilize Akka. That's how we can utilize the system design within the Akka cluster to get rid of the three most painful and largest problems with long polling. I hope that was of interest to you. If you have any questions, I'm very happy to answer them. And in case you're interested, get in touch with us.
Great stuff. Thank you so much, Mike. That's a great presentation. I'm really enjoying these sort of masterclass style presentations. If anybody has any questions, I don't see any actually at the moment for Mike, but I really encourage anybody to either drop your questions directly in the chat or the Q&A section here, or you can tag or reach directly out to Mike in the Hopin platform or through LinkedIn and connect with Mike there. Mike, thank you so much for your presentation. I'll let you leave the stage now. I think it's really interesting. Thank you. I did see a question come through from Mike last minute there. So Mike, if you can still hear us in the Q&A section, you should be able to answer a question from Daniel. Welcome to the stage, Michael. Michael is development manager at Tillo, who's going to be telling you a little bit more about what they do and what they build. So Michael, I will leave the stage to you. Maybe just try and load your presentation first.
Cool. Thank you. I think everyone can see that now.
Yep, we can see you. Over to you.
Cool.
Thank you.
Great. Cheers, thank you, Samuel, and yeah, thanks for inviting me. I'm excited to be talking with you all today. So good afternoon, everyone. I'm Michael Norris. I'm the development manager at Tillo. I joined Tillo as a senior software engineer nearly 5 years ago before we went live with our API. I now manage the development team of 12 engineers across multiple disciplines. I'm responsible for building on and maintaining our existing core offering and delivering new and exciting products. You can find me on LinkedIn and social media at MST Norris. So you may be wondering, what is Tillo and what do we do? Tillo is the rewards, incentives and gifting network. We were founded in 2016 and our goal was to transform the digital gift card market. And what that means is that we connect the world's most popular retailers and businesses looking for exciting ways to reach employees and customers. Our clients purchase gift cards from over 1,200 brands in 16 currencies across 29 markets using our API. If you'd like to know more, I encourage you to check out our website at tillo.io or find us on Twitter at TilloHQ. Today, I'm going to be talking to you about our secure vault. I'll touch upon the problem it solves, its reason for existence, and I'll describe the challenges we face with performance and scalability, and I'll go into a little detail about what we did to overcome some of those issues. Before we get into what the vault is, I should start with a high-level view of our platform. Along the top, we have our retailers. A retailer's gift card offering may be provided by or powered by a prepayment processor who offer up an API for us, Tillo, to connect to. More on this shortly. At the bottom, we have our clients, the businesses who are buying the gift cards. And in the middle, bringing everything together, we have Tillo, who ourselves offer a single, unified, RESTful API for our clients to connect to and to buy gift cards through. So what is the vault? There are two ways that we work with a retailer for whom we sell their gift codes via our platform. The first way, which is our preferred way if it's available, is if the retailer is already using one of the main prepaid processors, as I mentioned a moment ago. This allows us to offer their gift codes in real time, potentially open value, and without the need for us to hold and manage stock. The other way is by means of us holding fixed denominated stock in a secure system which we have built and that we call the vault. We've created an internal API to aid with loading stock in, checking the stock levels, and taking stock out of the vault. So which retailers is the vault for? So the retailers who do not have a prepayment processor, or it may be a processor that we've yet to integrate to and that we decide to take on stock in the meantime. So you may have gathered already that we treat our vault just like any other third-party processor that we've integrated to. This allows us to treat a retailer whose stock we store in our vault just like any other, and offer it via the same platform and in the same manner to our clients. This is a very high-level overview showing the main components for the systems. This is our API and our hubs, where users purchase gift codes, run reports, and perform customer service-related tasks, amongst other things. Wrapper is another product we've built. Our clients use it to provide personalized URLs to their customers, and I won't go into further detail now, and it may be a talk for another day. Analytics is a Python Flask API with an Elasticsearch database, and this is where most of our high-level stats come from that are shown in the hub to our users, and it's also used to surface data for some of our reports. The Vault is a self-contained private web app providing an internal API for Core to connect to, and it's the subject of today's talk. The public subnet holds elastic load balancers that allow users to only reach Core or Wrapper, and Analytics and Vault are services that serve Core, and only Core can reach them. Within our internal network, there is communication between these different services, but end users can only communicate with our Core services as well as our Wrapper services. They cannot communicate with the Vault directly. So a request comes in to our API from a client. The request may be for a retailer, for a third-party processor, or the request may be for a retailer whose stock we store in the Vault. So how does the Vault work? Stock has a number of attributes that we need to know about and take into account when loading it in, besides the gift code itself. Firstly, which retailer does it belong to and what is the currency? Secondly, what denomination it is? And finally, what is the expiration date? We load the stock into a database where each row in the table is an item of stock. We then take into account each of these attributes when issuing stock out of the Vault, and that's what we're going to be focusing on. Every time a request comes in, we need to perform some validation and operations to determine which item of stock to take out of the Vault database and issue to the customer. Which brand is it for and which currency? Is the denomination available? We then select all of the stock in soonest to expire first, locate the first item, and update a number of fields to capture who purchased it and when. And then we return that stock item in the API response. We must do this without issuing the same item twice. And in software terms, this is called a race condition. And we mitigate this from occurring by locking all the stock that meets the above criteria. This is a problem, and we'll come back to this shortly. And these checks and operations are performed on each and every request that comes into a Vault. And this is also a problem, and we'll be addressing that too. So the request comes into the core API from one of our clients. They've requested a code from a retailer whose stock we store in the Vault. We have our internal network, which is not accessible to the public, only via core. Then our load balancers. And lastly, and most importantly, our primary data source. Currently, this is where all the work happens. Now, the Vault is clearly not an ice cream van, but being based in Brighton and Hove along the south coast of the UK, I thought it was only fitting to use a beach faring analogy. So if you'll indulge me, Tillo is a marketplace for pleasant things like gifts, rewards, and incentives that delight the receiver, just like an ice cream van. Imagine an ice cream van on a beach selling chocolate, strawberry, or vanilla ice cream to tens of hundreds of people daily throughout the summer. Now, Tillo's network attracts a growing number of customers. The top graph shows the steady growth of clients trading on our platform from our founding to today. This is the number of people who are buying ice creams. At the same time, the bottom graph shows the number of retailers selling on the network has also grown steadily. This is our selection of flavors. The number of different flavors sold each month also grew steadily. Note that during the pandemic, a new kind of customer arrived. Blue represents our underlying business, so chocolate, strawberry, vanilla, etc. And green represents niche, artisanal flavors of ice cream. So far, it seems like we can meet the scaling challenges by simply adding more ice cream vans. More flavors plus more vans is plus more customers equals more vans, right? So from the point of view of number of transactions, i.e. the number of ice creams sold, here is the growth from the very start in 2016 up until the end of 2019. If we add in transactions for January 2020, and then for February, and now for March, do you know what happens next or can guess? So boom, April 2020 brings a huge spike in volume. It is unprecedented, and if you remember, there was no spike in number of customers, just a modest and gradual increase. And note there was also no explosion in the number of selections served. Almost all of the new orders were for a niche flavor, a specialty in our selection. It was as if a couple of customers walked up to one of our ice cream vans and asked for 800 matcha flavored ice cream cones. And it wasn't just a single fluke. It continued in May and in June and in July. And this is where we're at today. 2 waves of incredibly high demand for a specialty. This graph shows the ratio of Vault transactions in green compared to third-party processors in blue by transaction volume. The Vault was catapulted from being a minority class, circa 10% of a small number of transactions, to serving the majority of over 2/3 or 70% of an unprecedented huge number of transactions. No fleet of ice cream vans is going to efficiently serve 800 matcha ice cream cones. So how did the Vault just keep on chugging? To recap, albeit simplified, this is the architecture of the Vault, or at least that's what it was, where all the work is being done in the database upon each and every request that comes in. While not necessarily best practice, it served a purpose and performed absolutely fine when the growth was steady, but not so much when the traffic spiked, and especially when the majority of that traffic was for a few select retailers. Every time a request came in, we needed to perform some checks to determine which item of stock to take out of the Vault next. So what is the problem with the Vault? The short answer, the above doesn't scale. We originally built the Vault 4 years ago when the overall volume of transactions through the system was significantly lower than it is today. The total amount of stock we were holding in the Vault was also drastically lower. Now jump to 3.5 years later, and in April of 2020, both of these factors had increased exponentially. We made the decision to rewrite fundamental parts of how the Vault worked because of these known bottlenecks when it came to sudden spikes in transactions, and the total amount of stock we would need to hold in order to continue operating a smooth service. Each of the aforementioned steps that are required to locate a single item of stock perform okay when there are a few retailers with a few denominations and when we're holding a small amount of stock for each. But it starts to break down, however, when there are lots of retailers with multiple denominations and when we're holding millions of items of stock, causing query times and consequently response times to increase. So improvements to the existing architecture, and one of the action that had the biggest impact initially without changing the underlying infrastructure was introducing a nightly scheduled process to archive stock that was sold the previous day. This kept the total amount of inventory that needed to be sorted and processed upon each and every request coming in to a minimum, so only the sellable stock. You can liken this to throwing away the boxes that the ice creams came in. Until now, we've been holding on to them. The main objective in changing the way the Vault worked was to eliminate performance bottlenecks by reducing the number of heavy concurrent queries in the database. Instead of executing a separate SQL query on each individual stock item, a single query is run to cache multiple stock items into a Redis cache. Retrieving data from the first in, first out queue in the Redis cache is much faster than from the database and does not have any performance impact by introducing another dependency. Now, zooming in a little, the yellow block here represents our Python microservice that manages the levels of stock we hold in the Redis cache, shown in red. Every 4 minutes, a process is run to keep the cache topped up, and it's configurable on a per retailer and denomination basis, so we have absolute control. Caching a subset of the stock IDs means they are quick to locate, and when we do hit the database, we're only locking the next row, the single item of stock to be sold, not the entirety of unsold stock for that particular brand and denomination. All the work is done upfront in a separate Python service. Introducing this two-step process in conjunction with archiving previously sold stock has meant that we can continue to service more customers and scale up appropriately and steeply without the performance implications. A somewhat simple change with big impact and huge benefit. That concludes my talk and brief overview of our Vault. So yeah, thank you all for listening. And Samuel has already mentioned this, but if you'd like to know more and see some actual code, come and work with us. So yeah, thank you. And back to you, Sam.
Thank you so much, Mike. Really interesting. Great to get into nitty gritty of your architecture and actually understand how that works there. Michael just mentioned, Tillo are hiring. So if anybody's looking to join them or join Michael's team, you can actually look at their roles directly on TechTree or on their careers page. Michael, we do have a question from the audience here from Namrata. In terms of how do you load test your application before deployment, how do you do it, and how do you see how it's performing in case of a sudden peak in requests?
So we've got multiple different environments, like development environments. So dev we use sort of internally. Then we've got a UAT environment that is treated like production, as that's what our clients integrate to, and that's what they do their user acceptance testing against. So we actually use a number of tools, but one that I've personally used is JMeter. It's a command line tool. You can sort of build up your request catalog, if you will. So you can obviously build up your request. There's obviously some authentication, because we do everything through our core code base. We don't interact with the Vault directly. We do obviously some load testing on that, but sort of get real world performance, we go through core. So obviously there's some authentication, and then using the tool in JMeter, you can build up your what's known as like concurrency threads. So you can say that there's a ramp up time that I ultimately want to get to, say, 200 requests a minute or 1,000 requests a minute over a 5-minute period, and step it up that way and sustain it, say, for half an hour. Or you may want to have a sudden spike and say, I want to get to, say, 200 requests, but in 20 seconds, and sustain that. And then see how the infrastructure and the system copes. Great,
thank you. That's really informative. I can see that your ice cream analogy has gone down well with Steve. He's asking about the match of flavors. So, Michael, thank you so much. It's really cool. Like I said, if anybody wants to get in touch with Michael, you can either contact him here directly or connect with him on LinkedIn elsewhere. Michael, I'll let you leave the stage. Thank you very much.
Cheers. Thank you very much, Sam. Thank you.
So guys, we are on to our last talk. It's going to be another 15-minute presentation. This time it's going to be from Sophia Alphazar, who is a software engineer at Leafgrow. Hi, Sophia. So everybody, Sophia is from a early stage company called Leafgrow. She's going to tell you a little bit more about what they do and some of their technical challenges. So Sophia, over to you. Thank you very much.
Thank you, Sam. So let me get ready here and present my screen. Okay, awesome. So, hey guys, my name is Sophia. I'm from Costa Rica originally, but now I'm living here in the UK, and I work for Leaf, as Samuel was telling you. I'm a software engineer at Leaf. I've been working there as a full stack developer for around 4 years now. Yeah. So for the people who don't know, Leaf is a tech company that provides end-to-end performance marketing services for e-commerce businesses. If you want to know specifically a bit more about Leaf as a company, you can visit our website, which is leafgrow.io. I can share it on the chat after the presentation. So, today I'm here. I wanted to discuss with you guys some of the challenges that we have been facing as developers in Leaf in the past few years. Before getting into specific details on what the challenges are, I'm going to give like an overview, a high scope of what our product is about. The challenges are divided into like the first two is more like developer infrastructure challenges. And then the last one is like the typical challenge that you face when you use for your product a third-party service. In this case, it's going to be Facebook Marketing API. So before I begin with the challenges, I wanted to explain a bit about the campaign insights. As I said, we are a marketing tech company. So this means that in our platform, the users are able to launch and manage their campaigns, their advertising campaigns. In that sense, we have also campaigns insights and reporting. I've been the lead developer of the campaign insights and reporting department for a while. So what are the campaign insights? The campaign insights, it's a way to be able to display all of the data that an ad or a campaign generates when it's running. We try to give our users a very understandable view of what is happening, and we try to make it as simple as possible. This is very important for the performance marketing team because if they have the precise data in a very understandable way, they're going to be able to make the best decisions to improve the campaigns and their performance. So overall, like a very high scope on how the architecture of our platform works, is something like this. It's nothing too complex, I think, to understand. So we have a front end, which is the client, which is right now we are using React as a technology, and then we have a backend, which is own logic, which is handled by the controllers, the models that are formatting the data, and their services that are communicating with the third parties applications. In this case, an example would be the Facebook Marketing API or the database. And all of this is communicating with the client through the API, which is in Express.js. So having this scope on how it works, let's get into the first challenge that we have faced in this type of industry. Which one of these are like that we have different types of insights for different types of campaigns. So what does it mean? Well, there's a lot of different types of campaigns that you can launch. Like when you're advertising, you can optimize by brand awareness, by reach, by link clicks, whatever you want to optimize your campaigns for. That is what we call objectives or campaign types. And when we are requesting insights for like the data that campaign is generating, some of them are shared between all of the campaign types, but some of them are specific for a type of the campaign. So we needed to figure out logic behind it in an algorithms to divide these functionalities so that we know exactly when we can have like a specific function that brings the common insights for all the campaign types. And when do we have to detect like exactly what type of campaign you are, so you have this additional information that we need to request. And then in here we have some examples of like if you're launching a conversion campaigns, something like this would be like the specifics of the conversions insights. And something like this would be like the specific that you want to show video views insights. So if you have a campaign that doesn't have any videos in its ads, you're not going to be able to display this metric, right? How, like, this is only specific for video views, so it's like an example. And the way we did this is like, once we get the common insights for all of the campaigns, we then go and make an additional analysis or conditional to check which campaign type are we dealing with, and if we need to get the specific insights for that campaign type. This is a very overview scenario, very tiny functions of what we call a controller, which handles the logic and communicates with the service, which is communicating with the third-party applications, and then the model, which is the ones that are in charge of formatting the data so that the client can read it. In here we come with the challenge number 2 of that we face, which is the dependencies of information. What this means is we have the problem that we have is like we have a campaign ID, and then to be able to get like the detailed insights of how that campaign is performing, we cannot just send the campaign ID to Facebook and tell me like return me everything. No, we need to have specific settings for that campaign available to be able to request another data. So it's like the typical problem that you need the general info of the campaign. The general info of the campaign can include, I don't know, the date ranges, the attributions of the campaign, the campaign main metric that is set up to be able to request the other sections of the campaign. So a lot of the information is dependent on the last information that you requested, or like or something else that a campaign has to be able to request, like the breakdowns or stuff like that. So in this dependent, what we had to figure out is we needed to make like a synchronous design between the controllers and their service. So this way we could wait until we have the information that we need before continuing to the next step. And here's a very simple example of a synchronous design. We need to have the campaign breakdowns before we make the request for the engagement campaign, for example. So you can see here that synchronous architecture. And then the 2 challenges that I mentioned before are very, not normal, but everyday engineer challenge that you can face, that we need to figure out how's the best logic, how's the best infrastructure that we need to create, how can we make this more efficiently. And the third challenge, which is one that I want to highlight the most, is the typical challenge of like if you depend on a third service for your product, in this case, Facebook Marketing API. The reason that Facebook Marketing API is challenging is because Facebook itself does not make money by the people who actually uses the API. You know, Facebook has its own platform that you can launch campaigns through them. They're making a lot of money on advertising, and then they offer the service of, okay, you can request my data through my API, but it's not like their main service to offer. If you compare the first Facebook Marketing API to an API that is mostly based on that, like the API is the service, like for example, Stripe. Like Stripe API, the documentation has to be very good. The service that they give to developers has to be very good because they make their money out of it. Like people need to use their API to integrate Stripe to their website for them to succeed, let's say. In Facebook, it's not that way. So Facebook actually has some challenges that I'm going to mention in the next few slides that we needed to tackle as a team of developers. And then in hand with this challenge is also that the product is very young and it's still growing. So we are a very young, actually, tech company, and our product and our stakeholders are every day discovering what they actually need in the platform. So we need to make our code very adaptable for changes in the future. In an example that I found was like the breakdowns. Like when you request insights of a campaign, you can request it, break down the data, let's say, into sections. Right now we support in our platform age, we support country, gender, like all of the insights breakdown into these sections. But we could have more breakdowns in the future. The way that we did that is that we made the code adaptable in the future. Right now we have a list of the breakdown types, and if in a future we just wanted to support another type of breakdown, it's just a simple step of adding it to the list and everything should work fine. So that's where we try always to aim to think about how can we make this code super adaptable, so in the future, if we need to expand it, we make the less code changes as possible, let's say, and we will be able to support it. And going back to the Facebook Marketing API, I just wanted to give a glimpse of like the difficult, like the little, why is it difficult sometimes to handle the Facebook Marketing API, and why you have to really do research and get to know exactly how Facebook works underneath. In this example, let's try to think of a very simple metric that you want to see. You want to see how many purchases have your ads generated, let's say. Sounds very simple. Sounds like you probably just send like a campaign ID and just the word purchases, and hopefully Facebook will return like the number of purchases. But it's actually not exactly that simple. First, you need to know what metric are you going to request, because Facebook does not give you directly like the purchases. It gives you a list of actions. The actions can be everything, any action that was produced by your ad. So post reactions, video views, post engagement, clicks, all of those are actions. And once you get this list of actions, you need to go and check and find which one of those are purchases. And sometimes the naming on the action type is very different from what you call it in client. So there's a lot of research done. Like every time you want to add a metric, there's a lot of research done behind it. And sometimes you also face discrepancies between the API of Facebook and what you see in Ads Manager. So for example, in this case, we had a campaign that in the Ads Manager, it was displaying 439 purchases. But through the API, Facebook was returning us only 391. So we were not sure why the number was different. And then after some research, we decided to actually contact their support system. And the support system, at the end, the solution was very simple. It's just that in the same endpoint request, we needed to send like an additional parameter to set the attribution settings of the user account true. So then, like what this means is that Facebook measures like every event in a length of time, let's say, like purchases, if you saw the ads in the last 3 days or something like that. So it counts as a purchase. So sometimes they always return through the API the default, unless you set these user account attribution setting to true. If you do this, then the return will be whatever the user has set up in their account in Ads Manager. So this is actually the one that we want, because if not, we're going to give them the overview of purchases, but in a different timeline, let's say. This was something that was not in the documentations of the insights whatsoever. Like they had some documentation of it, but it was not in a specific section of the insights. So this is the kinds of things that you really need to get to know and experience is your best friends when handling these kind of difficult APIs, when the documentation sometimes is a bit shallow, per se. And once we do that change, we managed to have the correct data that we needed for the purchases. And yeah, in overview, this is like 3 of the main challenges and solutions that we have faced in the last few years working at Leaf, and how we are always improving our code. A lot of the things that I mentioned are changing bit by bit. For example, the screenshots of the code that was in JavaScript, we already changed it to TypeScript, and we are always improving. But yeah, overall, that's it. I don't know if anyone has any questions.
Yeah, thank you so much. That's a really interesting presentation. I think slightly different approach to the presentation we had so far. So I'm really interested in more about that. Great to see more about Leaf. I think we have a question from the audience here from Rohith. Is it focused more towards Facebook ads, or is it common for the other ad platforms as well?
Right now, we handle campaigns that are launched through Facebook, Instagram, Messenger, and we are starting to integrate also Google. So it's not exactly always Facebook, but as you know, like Instagram is owned by Facebook, for example, and Messenger as well. So a lot of it is handled through the Facebook API. So that's like the main core of it. But yeah, where we handle like different type of platforms, and our performance marketing team also launch in other, even in YouTube and stuff like that. But in the platform, in the product itself that we have, we offer the campaign overview and the data insights mostly on those that I mentioned, Facebook, Instagram, Messenger.
And we have a question from Daniel. As you said, the external APIs are forever changing, and they're changing over time. How do you model that within your app?
Yeah, that's a very good question, and we could be having discussions for that for like hours. But yeah, that's actually something that internally we have been doing a lot of changes in the infrastructure, being able to store a lot of the data in our database as well. Because yeah, it's changing. Like every time Facebook has a privacy policy that needs to change, sometimes there's data that you were able to request before that you cannot request anymore. So we have a team actually also on top of the change logs of the versioning of the API all the time. And every time there's like a new update from Facebook that maybe they're going to change something, we always try to do a very big research on how would that impact our platform. So hopefully, normally Facebook announces like a few months before the change is actually implemented if they're going to do like a big change, so you have time to prepare. But yeah, we are constantly always modeling that in our app, mostly in the infrastructure team that we have. Those guys are always on top of that, seeing how we can always tackle that in the future. But yeah.
Right. Awesome. And you just touched on it just like that. I guess we would love to know a little bit more about what does the engineering team look like now? How many squads or teams are you currently at? Are you looking to grow, obviously, and any specific requirements that you think people excel in when they join?
Yes, no, exactly. No, the tech team is actually growing a lot. Right now, we're in the process of hiring constantly. I think we are around 20 engineers, maybe. I'll have to do the math. But like just last week, we have like 3 new incomers, and we are constantly hiring more because we are like in this process right now. We're a startup company. We are in this process right now of rocketing, let's say, our application and our platform, and actually improving our platform altogether. So we are constantly looking for mostly software engineers, always seniors, hopefully around also a mid-level would be the best. But yeah, I can share some details if you want about like any career path for the future. Yeah, in the chat.
Amazing. Thank you so much, Sophia. Great to hear how sort of Leaf is growing and a bit more about what you're doing internally. I'll let you leave the stage and I'll wrap up. Thank you so much.
Thank you.
Thank you. So guys, thank you so much for joining the event today. That's a wrap, and that's all of our speakers today. I just want to end the event by having a quick shout out for our partners again. So a big shout out to TechNation, Upscale, and Liam, who we heard from at the beginning of the event, for supporting us on a second TechNation event. It's great to hear from the companies that they have and their sort of acting as a catalyst for. If anybody has questions for TechNation, you can reach out to Liam Ward directly on LinkedIn or still in the chat function if he's here. If you have any questions for the speakers, so a big thank you to Atom Learning, Tillo, Blink, and of course Leaf. If you have any questions for the speakers, you can contact them directly on LinkedIn. And if you want to check out their jobs, you can also look at either the booth sections here or on their career pages too. And the final shout out is to Silicon Roundabout, who's been our partner on this event for a long time. A huge thank you to Francesco and their community for supporting our events. Hoping to see more of them in the future. So guys, that's it. I would say keep an eye out for our upcoming Show the Code events. We're going to have lots more presentations from engineers, senior engineers. We are looking to include more talks that are slightly longer focus, where it's a masterclass style workshop. So I encourage you to stay in touch there. If anybody has any questions about TechTree or directly for me, please feel free to either drop me a line on LinkedIn or by my email, and I'll be sure to help out. I think that's it for now. So thank you very much for attending, and see you next time.